This is a video on Newton's second law of motion, how to calculate force. All right, how much force is required to accelerate a 5 kilogram mass at 9 meters per second squared? Well, let's start with our formula first. Force is equal to mass times acceleration. So let's find that in our word problem. Our mass is 5 kilograms. You must remember your units. Units are very important. We could be talking about 5 pigs instead of kilograms. Very important. We also know our acceleration, which is 9 meters per second squared. So we know everything that we need to know to figure out the force. Let's go back to our formula. Where we have m, we're going to put 5 kilograms. And where we have a, or acceleration, we're going to put 9 meters per second squared. And now we're going to multiply them. 5 times 9, which is 45 kilograms times meters per second squared. But that is a really long way of writing that. And it's equivalent to us saying 45 newtons. Kilograms times meters per second squared is the same as saying newtons. Let's look at another type of example. All right. What is the acceleration of a 15 kilogram mass pushed by a 5 Newton force? Well, let's write our formula first. Force is equal to mass times acceleration. Well, now there's a problem here because we know what force is and we know what kilograms are, what the mass is. But we're missing this acceleration. So we're going to have to move our formula a little bit to figure out and get acceleration by itself. So to get acceleration by itself, right now mass is being multiplied by acceleration. We have to do the opposite. And the opposite of multiplication is division. We're going to divide by mass to get our acceleration by itself. But what we do to one side, we have to do to the other. And now this mass canceled out, and we have a by itself. So I'm just going to rewrite that. A, or acceleration, is equal to force divided by mass. Here's our new formula. Because we know what force is 5 newtons, or 5 kilograms times meters per second squared. And we know our mass, which is 15 kilograms. So let's plug it into our new formula. Force is 5. We're going to write the long way so that we can see our units cancel out. 5 kilograms times meters per second squared over 15 kilograms. And this is going to be equal to, well, let's cancel out this kilogram because we can divide that. This is going to be equal to 0.333, repeating. And our units are going to be meters per second squared. Those are the units for acceleration. Now, if we were going to round this, we would round it to 0, well, let's say to the tenths, because that's the easiest spot. We're going to look back. This is below a 5, so we're going to keep it the number it is. So 0.3 meters per second squared. Let's look at another type. All right. What is the mass of an object that requires 50 newtons of force in order to accelerate at 5 meters per second squared? All right, well, let's start with our formula. Force is equal to mass times acceleration. But we're not looking for force. We don't know what our mass is. So let's rearrange our formula. To get mass by itself, we have to divide. Divide acceleration. But what we do to one side, we have to do to the other. So we're going to divide by acceleration. Let's rewrite this because those two cancel out. So mass is equal to force divided by acceleration. Right now, we know our force is 50 newtons. But we're going to rewrite that the long way to see our units cancel. It's going to be kilograms times meters per second squared. And we know our acceleration is 5 meters per second squared. So let's plug it into our formula. Our force is 50 kilograms times meters per second squared over 5 meters per second squared. Well, we can cancel out these units, get rid of that, and get rid of that. We're left with just kilograms. So these are going to be our units, just kilograms. And when we do the math, it's going to be 10 kilograms.